Hello, Assalamualaikum. Welcome back. Okay, now we look at second part of vector application. Okay, this is plane. Okay, plane. Like my book, I consider this as a plane. Alright. Okay. So if you have a plane macam begini, like this, so you will have a normal on your plane, 90 degree. So in this case, if this is your plane, so you will have one vector going up or going down with 90 degree. Okay, angle 90 degree. So we can say that this is our normal, and then AR is perpendicular to N. Okay, this is your vector A. A is on the plane, any point on the plane. So vector from A to A we consider as perpendicular to N. So this angle is 90 degree. And R, X, Y, Z are any point that moves in your plane, right? So and vector n is given by alpha I plus beta j plus gamma k, or you can write in column vector alpha, beta and gamma, right? Okay, so that r is moving on in the plane. So for our plane it requires criteria as follows. Okay, a plane in space has normal vector n, okay, a b c. Whenever you have a plane, there must be a normal vector, and that it passes through the fixed point A, x1, y1, z1, or you have a plane passes through three fixed points. Okay, for example, like this is your plane. So there are 3 points on the plane, okay, where you can find the equation of plane if you have 3 coordinates given to you. Okay, or a plane has two vector. Okay, one vector and another one is here, two vector. All right. Okay, these are the criteria. So in order to find equation of the plane, we have r dot with normal equals to a dot n. Okay, where your r is position vector of r, x, y, z, and a is position vector of a, x1, y1, z1, and n is the normal vector to the plane. Okay, so you must remember this equation. In order to find equation of a plane, what you need, normal, position vector of a and position vector of r, then you have r dot n equals to a dot n. Okay, multiplication dot product or scalar product of a dot n, you will get a constant. Okay, how we find vector equation of a plane? We need a given point on the plane and then a vector normal to the plane. In order to find the equation of this, you need a point and you need the normal. Okay, you need a normal which is 90 degree to the plane and any point on the plane. Okay, next is Cartesian equation for a plane. From r dot n equals to a dot n, you will have this expression. If your r is x, y, z and n is your normal alpha, beta, gamma, this one also alpha, beta, gamma, then your a is the point on the plane x1, y1, z1, then we will find the dot product x alpha, y beta, z gamma equals to x1 alpha 1 is a constant, y1 beta 1 is a constant, z1 gamma is also a constant. When you add together, you will have a phi is a constant. Alright. Okay, or we can rearrange this constant in front equals to alpha x1 plus beta gamma 1 plus gamma z1. Then this is the equation of a plane. Okay. Okay, for example, okay, let's look at the example. Find the vector equation, and second one, Cartesian equation for the plane passes through A and it is perpendicular to vector 2i minus j plus 3k. Okay, so in order to find the plane equation, you will need this in general, right? So we know that, okay, we know this one. Your plane is perpendicular to the vector, meaning that this is your vector normal, right? So we substitute inside here, okay? And then this one coming from given here. Your plane is, there is a point passes through your plane A170. So this is the I plus 7j plus 0k. Your point A just now is 170, right? So plus 0k, and then we find the dot product of this, then we get negative 5. So negative 5, r is, vector of r is x, y, z. Okay, so we will have vector equation for the plane is r 2i minus j plus 3k equals to negative 5. So the Cartesian equation for the plane is 2x minus y plus 3z equals to negative 5. So if they ask you to find vector equation, we will leave it as this form without substitute r, x, y, z. But then Cartesian equation, then you substitute r, x, y, z, because vector r is x, y, z. Okay, so you multiply with 2, negative 1, 3, then you get this answer. Okay, next is, okay, next equation. Find the equation of the plane with normal vector I plus 2j plus 3k. You are given n. Okay, n equals to I plus 2j plus 3k, and with the point, this point lies on the plane. So very easy. You have your normal and you have the point. So using the general formula, r dot n equals to a dot n. So r is always x, y, z, and n is 1 to 3, 1 to 3, here also 1 to 3, a is negative 1 to 4. Okay, and then this one you multiply, negative 1, 1, plus 2 and 2, plus 12. Then you get 15. So this one is x plus 2, is 1x times 1x plus 2y plus 3z. Okay, then you get the equation of your plane, right? In other words, if you sketch the plane, so this is your plane, there is one point here, negative 1, 2, 4, and you have a normal vector like this. Okay, normal vector 90 degree, which is 1, 2, 3. Right? So this equation x plus 2y is the vector, the equation of this plane. Okay. Alright, find the equation of the plane through A, B, and C. Okay, they didn't give you the normal. Alright. Okay, you have this plane. It's given that this plane, and you have point A here. Oh, wait a minute. You have point A here, and you have point B here, and you have point C here. Okay, because they say that the three equations are on the plane. Okay, on the plane. So don't confuse. You have a plane, you have 3 points on this plane. Okay, so now how to find the equation of a plane? You need r dot n equals to a dot n, right? So a, you don't have any problem because you can choose either 3 here. But now your problem is to find normal. Okay, so previously, okay, from the first part of vector, we can find normal by finding cross product of two vector, right? So you can choose from here, find the two vector. Okay, how they find here. Okay, so they're using AB. Okay, AB, find this vector AB. So you get 4i minus j plus 3k, and AC. Okay, can AC is 2i minus 2j plus 3k. Alright, so now you get two vector on the plane. Okay, but then make sure if you are choosing A to B, okay, A to B, then the other one must be from A as well. If you're choosing from B to A, then the other one will be B to C. Okay, it must be pointing on the same point. If you're choosing A as your fixed point, then you must pointing from A. Okay, if from B, then from B. If from C, if you're choosing from CA, then you must choose the other vector will be C to B, right? So n is the normal vector, then n is the cross product of AB and AC. Okay, when you do cross product of two vector, you will get, okay, a normal. Okay, a normal from these two. Alright, a normal from the two vector. Okay, so this one you already covered in the first part, so you get the normal. Now you have the normal equals to -1, -10, -6. Okay, so since you are choosing from A, then when you substitute the R in this equation, choose point A. Okay, okay, you see here point A -1 to 0. So they will use point -1 to 0. But then if you're choosing from B, then you choose your A as your B coordinate. Alright. Then we substitute and then find the dot product right and left side. Then you have this equation. Okay. Clear again? Alright, next. Show that the line whose vector equation, okay, this is the equation of the line, is parallel to plane P whose vector r dot I plus 5j plus k equals to 5. Okay, how is it? L is parallel to I negative j plus 4k and P is normal to I plus 5j plus k. Okay, now we can say that macam begini. It's like this. This is your plane. Okay, oops. You have this plane, alright, and this plane, you know your normal is given here. N is 1, 5, 1, kan? Okay, your normal. And this is parallel to vector equation ini. Parallel to vector equation ini. So it might, but then this line is not on the plane. It's just saying that it is parallel to the plane. So it can be somewhere here. Katalah is your L. Okay, so you know from here r equals to 2i minus 2j plus 3k equals to t multiply with I minus j plus 4k. You know your direction vector here is 1, -1 and 4. Okay, this line is parallel to here. How we show that they are parallel? We can consider the direction vector and their normal. Okay, because if you continue this vector going up and this one to the right, we can say that this will be 90 degree. This one should be 90 degree. Okay, if this is 90 degree, meaning to say that your direction vector of the line and the normal, their dot product should be 0. Why 0? Because this is coming from dot product modulus of I minus j plus 4k multiply with modulus of I plus 5j plus k cos theta. So what is your theta in this case? In this case is 90 degree. Okay, so cos 90 degree is 0, kan? Cos 90 degree is 0. So 0 multiply with this modulus will be 0, so that's why you have 0 here. Okay, so we can say that L is perpendicular to normal P, and hence it is parallel to P. Okay, next, find the Cartesian equation for each of the following planes. The plane passes through A, 6, negative 7, 4, and parallel to X, Y plane, and B is YZ plane. Okay, that plane is passes through this point and it is parallel to X, Y plane. B is YZ plane. Okay, XY plane is on the line Z equals to 4. Y, okay, if you sketch that XYZ, XYZ, okay, your plane is passes through 6, negative 7, 4 and parallel to XY. Where is your XY? This is your XY. Okay, this is your XY, and then it is parallel to XY plane. So if this is your XY plane, okay, and it is passes through 6, negative 7, 4, meaning to say your Z is at coordinate 4 here. So you are considering the plane that on the Z equals to 4, somewhere here. Okay, with X 0 and Y also 0, it is somewhere here. Passes through coordinate Z equals to 4 because your A is 6, negative 7, 4. Okay, so that's why you have this, meaning that is 0, 0, 4. How about YZ plane? YZ plane is on X equals to 6. Okay, let's say you have this X, X, Y, Z. So where is your YZ plane? YZ plane is somewhere here. Okay, and it is parallel YX equals to 6 because it must passes through this point. Okay, your X is 6, so it's somewhere here, 6. So our graph should be somewhere vertical. How to sketch this? Vertical and passes through this point somewhere. How we can here is okay. So it should be vertically here. Somewhere like this. That passes through this X equals to 6, meaning that 6, 0, 0 should be like this. Okay, so that's why we have this answer, Z equals to 4 and X equals to 6. Alright. Okay, next is finding angle between two plane. Finding angle between two plane. Okay, if you have this plane, yellow plane and green plane, so their angle will be this angle here. Okay, so something like if you are having two planes like this. Okay, so one plane and one plane here. Okay, like this. Okay, like this. So where's the angle? The angle is somewhere in between the two planes. Okay, so how we consider the angle? We will just take out their normal, n1 and n and m. Okay, so the angle between two planes is the acute angle formed by intersection of the planes normal. Alright, So how we find? Same like the dot product. n1 dot with n2 equals to modulus of n1 multiply with modulus of n2 cos theta. We want to find this. So you rearrange everything. This one you bring to the other side. So cos theta equals to n1 n2 over multiplication of modulus n1 and n2. Okay, so for example like this, find the angle between the two planes. So you just take out ini, the normal. Okay, find the normal. Alright, so cos theta equals to 2i 2jk multiply with ij negative 2. We'll find the modulus. So 2 times 1, 2 plus 2 minus 2. So this one is 2 square plus 2 square plus 1 square. 4, 4, 1, 9. Set 9 is 3. 1 plus 1 plus negative 2 square is 4, 6. Set 6. Okay. Then you get this. So theta equals to 74.2 degrees. Should be acute. Right. Okay, that one is for angle between two planes. What if we want to find the angle between a line and a plane? Okay, one plane and a line. Alright, so angle between a line and a plane is, this blue is your plane and the yellow line. So the angle will be angle of A. Okay, angle of A. So how we find the angle between a line R equals to A plus TB and the plane R dot N equals to B is given by cos B equals to cos 90 minus A equals to sine A. So N dot B, same thing, we are using the same formula. N dot B equals to modulus of N multiply with modulus of B sine A. So giving A. So A equals to sine inverse n dot b over modulus of n multiply with modulus of b, or okay, or if you have a plane like this, okay, if you have a plane, this is your P, so this is the line, right? This is the line. Okay, this is your normal. Okay, so if this is the angle that you want to find, so here is B. Okay, so you have R here. You can also use cos theta. Cos theta equals to direction vector of R, which is B. B dot with N over modulus of B modulus of N, but then you will get this angle B. Okay, you will get angle B. What is angle B? But then our aim is to find A. So what is A? A equal to 90 degree, because this is 90 degree, multiply with B. Either one. You can choose either one. If you are using cos, then you must do this subtraction. If you are using sine, then you will get directly the answer. Okay. So let's look at the example. Okay, example 7. Find the angle between the line 2i plus 3j plus t multiply with I minus j minus 2k and the plane R dot with I plus j minus k equals to 4. Okay, if you are using sine, you will get the answer directly. Okay, so sine theta equals to 2 over sec 6 multiply with sec 3, 28.1. Or if you are using cos, okay, this case is like this. Okay, the plane, this is the plane. All right, so your n is 1, this one, this is your n. So 1, 1, negative 1, this is your n. Okay, then your direction, vector line. R is 1, negative 1, negative 2. Okay, so previously you learned that if you find the dot product of the two vector, you will get this B, right? So cos B equals to 1, 1, negative 1 dot with 1, negative 1, negative 2 over modulus of normal and modulus of direction vectors. Let's say I denote as V. Yes, so I will get B. But then the angle between line should be A. Okay, because this is your plane, this is your line. The angle between line and vector plane should be angle A. So how to find A? A equals to 90 minus B. Okay, you will get the same answer. Right, so I think that's all for application vector part 2. So if you have any question, then you can just accept or comment on the smart matrix. All right, see you. Thank you.